Aloha, Ohana. I'm making a recording of what we did in class today, and I will see. Pull up this PowerPoint first of all. We're looking at a linear regression, and what a linear regression does, if you have a bunch of data points, and actually, let me pull up. Actually, I think this would be pretty cool. So if we have Old Faithful, I'm going to look at insert. So we have this data set. How do we make a model out of it? I mean, you can right click and do add trend line, and really that will give you display equation on chart. That will give you a linear regression, and that's pretty handy. You make sure you have the right x and y variable in there. So when we're looking at this, how do we determine the model fit? What you do is you look at, you can draw little lines from the point and to minimize the space between the line. The one issue though is if all you do is simple arithmetic, you take the difference between these points in the line, you can come up with this line. You can have things that cancel each other out. You end up with a line that looks like that. And so to get around that, the ordinary least squares, the square part is you take these differences and then you square them, and then you sum them, then you minimize those. That will give you the OLS, or the ordinary least squares line. And it has some really interesting characteristics, and that can be very useful. And that's what we're covering with this part of the course. You have y is your output variable. You have a bunch of input variables that get fed into it. When you're running these, there's a whole bunch of names that get thrown around. These are a whole bunch of common names for the x variables: independent x, explanatory, the argument of the function, exogenous variables. For the homework and the exam, I'll keep it simple. Let's call it x and y, or at least I'll make some reference in there, so it should be fairly clear. We have the linear regression. If you look at the data, first of all, if it looks like a hot dog, or basically a fairly straight line, I mean, you can do linear regression. If there's some structure in there, if it looks like a hamburger, like for example, like this one right here, this is more like a hamburger. You have inconsistent, there's a pattern where it's more narrow at the ends and wider at the middle. That tells you there's some sort of structural pattern in it. So you'll probably want to convert that, do a bunch of fancy math and turn that into a line. There's some fancy tests that are beyond the scope of this class to determine what the best model, but at least for this, I think you could do a visualization. It looks like you can fit and be pretty good. The banana one, this is not a straight line. And so this looks like a quadratic equation. You'd want to do some fancy math to convert it to a line, which we're going to do it, which we're going to minimize the data points and the line that you have. Okay, so there are a couple things you'll want to check on. Look at the F-test for model fitness. If it's within 5% or less, then you can fail to reject the model. I mean, that's about as close as you get to in statistics to saying accept. You don't really say you accept something, but you fail to reject. That's about as close as you get to it. You want an R-squared of at least probably about 2/3. You do a t-test on the variables. You'll want to keep that within about 5%. We'll look at a couple examples when we have that. The sign of the coefficients is really important, and the magnitude of the coefficient. And they're really powerful, and you can use that to help interpret things. One more thing I'll add, you can have if you have a bunch of data with numbers, that's easy to interpret. What happens if you have categorical data? If you have categorical data, you have something called dummy variables. And what you'll have, the example I have is if you have male or female, whichever one are all zeros, that's the base. And so in this case, if you have males is 0, females is 1, you have one variable for gender. So, and what this tells it, when you run the regression, you look at the coefficient that's tied to this variable, to the gender variable. And because female is 1, what that means is if you have the value of that, if it's positive, that means if you're looking at, for example, wages, if the coefficient is positive, that means females make more than males. If it's negative, that means females make less than males. Well, it's really cool. You look at the number, it can tell you the magnitude. So if you have a value of 0.2, that means females are making 20% more than males. If you have a value of -3, that means females are making 3 times less than males, and what the base value is. And you can swap the male and female, or whichever one is the base value, as long as you make sure you're consistent. If you have, for example, want to look at, if you have 3 different colors, let's make it base yellow. And so we'll use these variables. In your data set, you'll have blue or green. If they're both 0, that's yellow because that's the base. If you have blue equals 1, that means the color is blue. If you have green equals 1, that's the color green. So when you run this regression, whatever value you have on blue coefficient will tell you the difference from yellow. Whatever value you have with your green variable will tell you the difference from green. And you can set these up with however many items you have within that category. Okay, so there's a little bit about the intuition behind what we're doing. Let's look at some examples that we have. One example that we have is with the Old Faithful data, and I pulled that up here. I graphed it, and with the Old Faithful data, it does look kind of like a hot dog. I mean, you've got a bunch of variables here and a bunch of variables there. So maybe there's some structure, but if you were to draw lines at the upper and lower bounds, it's relatively straight. And so I think maybe I'm going out on a limb, but I'm going to say we can run ordinary least squares on this. If you only have 2 variables, it's really easy to see that. When you start adding much more variables, that gets a little more tricky. You have to use some more fancy procedures to figure out what's going on. And okay, so now that you have this data, we're going to create it. Now that you have this data, what you might do is let's run a regression. And to do that, you click on data, which is right, the data ribbon, which is right here, and the data analysis. If you don't see data analysis, the way you add it is if you click on file, which is over on the left-hand side, the ribbon all the way furthest on the left, you go to the very, very bottom where it says options, and that's the next thing you want to click on. When I click on that, this thing will come up, and then I want to click on the add-ins. And the add-ins is, click on that. The very first one, the type of add-ins is analysis tool pack. That's what I want. I want to make sure I have Excel add-ins, and then I click on go. And that will bring me to this thing right here. And I want to click on the analysis tool pack. Now, earlier today and yesterday, I couldn't open this up for whatever reason, but there's a glitch with 365 sometimes. And so what I found, I talked to Dr. Google, and I got a suggestion that you come in here, you unselect it, click OK, and go through and select it again, and then it should be there. And that's what happened today. So now I have it. We click on data analysis. And of all these options, I'm going to pick the one that says regression. I'll click OK. The Y range, this is what we're going to explain. That is, let's see, this one, Old Faithful. Make a scatter plot, see, based on the scatter plot. And for the model, we're going to be using the Y range is duration. So I'm going to put that in here. What is it? A1 to A273. The X range is going to be B1 to B273. And I'm going to output in the same worksheet. You can do that, or you can give it a new new worksheet instead of the same way. Click OK, and we've got the regression. Let's take a look at a couple of things on this. We have an R squared of 81%. That looks great. The F test on model performance. The significance of F is well below 5%, so the model must be good. let's look at the p-value of the t. We'll do a t-test, and that's this thing right here. That looks really good. And what this tells us, and so the model looks great. The variables look great too. And so the way we can interpret this is we look at the weight coefficient. We have a value of 0.07563. What does that mean? That means for every minute that we wait, we'll have 0.07 duration of the geyser going on. And so what happens if we wait 60 minutes? We're going to do equals 60 times that period. That means if you have a 60-minute wait time before the geyser erupts, you can expect there to be about 4.5 minutes of nonstop eruption. It is going to be plus or minus. We have some, with 95% confidence intervals. And so you can anticipate, what is it, 4.25 minutes, I guess 4 minutes, 15 seconds, and 4 minutes and 45 seconds. That's where you would anticipate, that's where it'll happen most of the time. Great, so that's using Excel. We can do the same thing in SAS. I have this data over here. When I run it, I'm going to run the scatter plot first of all. If I run that, then that gives me the scatter plot. The weight on the x-axis, duration. Oh, I guess you can, yeah, that's good. And you can swap it however you want to run the code. To run the regression, you write proc reg, that's because it's a procedure, data equals, that's the table we're doing. Oh, I'm sorry. Let me look at for this. Is that okay? Oh yeah, that's right. The proc reg, because we're doing regression procedure, data equals faithful, that's the name of the data set. The model, the first one is y equals, so the duration equals x. When I run this, there, we get really the same results that we had before. The R squared, 81%. Look at the model fit, same F value, 1162.06. So you look at the significance, the probability that we fail to reject, it's very, very small. So that's that one. If we look at the t-test, probability is very, very small. And then we look at the parameter estimate, it's the same for both of them. Great. So now that we have that one, let's look at some of the questions on here. So we failed to reject this model. True. True. We failed to reject it. We failed to reject the coefficient too, because it looks great. And let's look at the next one. We have cars. There's a couple ways you can do this. We'll go ahead and close out. I'm going to grab the car prices, and I'll do it in Excel first, and then I'll do it into SAS next. Just a minute. And I've got the SAS data set that you can upload into the student version. So, oh, I got it. Okay, we have a model where we're looking at the price. Okay, they'll be explained by mileage and what type of a card. So here we're going to use the dummy variables. If I look at the data, I just have this Buick, Cadillac, Chevrolet, Pontiac, Saab, Saturn. And okay, I'm going to do price, and then I'll set that equal to, what are we looking at? B2. And I'll go to that all the way down here. Populate that. Okay, the next we want to have in there is mileage, and then it would say Buick, Cadillac, Chevrolet, Pontiac, Saab, and then George. So something about mileage is going to be into Buick equals, we'll do an if then statement. If, what is it, C2 equals P1, we'll give it a 1. Otherwise, we'll give it 0. And then we can just, you'll notice that I anchored the row in P1. Oh, I need to anchor on the P2. So if $sign C2 is equal to P $1, now it copies all the way. So that will give me a value of 1 if it matches what the column header is. And doors, that's I2. I'm gonna have that. And if I want to check this, that'll give me 1 for all of Buick. Yep. I could do it for each one. What if I have no Buick? And look at the make, and Buick's not in that. And I could do that for each one, but I'm pretty sure my phone will be closed. If I'll take the exam, I might check this, double check to make sure. Okay, now I've got everything all together. You have to keep them all together when you're doing a regression in Excel. So it's not as handy as SAS. Let's look at this data analysis. And then I click on regression, okay. The Y range, we're looking at the price. I'm going to include the label, okay. And the X range, we've got all these variables in here. I'll include each one of those. Output to W1, click OK. And that gives us our model. All right, so if we look at this, we have an R squared of 72%. That looks pretty good. We look at the model fitness, the F score, that's really, really small. So that's good. And let's have a pet peeve because it repeats so. So if we look at each of the variables, the p-value, all of these are less than 0.05. And so that means we have a really good model with this data set. How do we interpret this data? This first one right here, we look at the coefficient for mileage. That has a negative value. That means for every mile you drive, your car loses value, loses 17.5 cents, about 18 cents. These are all base Saturn. And so what this means is how do these prices differ from Saturn? So if it's a Cadillac, you're looking at 27.8 thousand more for being a Cadillac as opposed to being a Saturn. It looks like the Saturn is a low value of all of these. If we had picked one of these middle ones, some of these will be positive, some will be negative. And really, it just tells you what the difference is from the base. And the doors, it looks like each door takes away about $2,700. And that's because sport cars have fewer doors. So if you have 2 doors as opposed to 4 doors, your car is going to be, if you have only 2 instead of 4, that means your car will be about $5,500 more in value. If you have 4 doors instead of 2, it'll be $5,500 less in value because each door takes away that much value. If we want to build up a car, I'm just going to put in some figures right here. So mileage, and it's a Pontiac with 4 doors. What this model is predicting is you take the intercept plus, let's see, let's get some values in here. Let's say you have 20,000 miles, and that's a Pontiac. You have 4 doors. So what is the value of a car? We take the intercept plus we take the mileage, X variable times the coefficient. And then the fact that it's a Pontiac, so 0 times everything but 1 times Pontiac. And then you have the number of doors times the door coefficient. So if you're selling Pontiac with that many miles, you can anticipate selling it for that price. That's how we do it. So this is using Excel. How do we do this with SAS? I'm going to open my SAS, and I have. Let me open up one of these. Actually, first of all, I want to upload some data. So over here on the left, I'm going to upload some information. Click on upload and choose file. And if you want to download that from Canvas, put it wherever. This is where I saved it to before I uploaded it. There's a file called cars, and it says .sas7 bdat. It's a data file. I'm going to upload it. And now it's on here. And I'm going to see what's cars. If I right click, do properties, where it says location, I'm going to copy all that part. Now I can include the code. So I'm going to data, a cars, set, within either single quotes or double quotes, doesn't matter. With it, but you have to put these sort of quotes. I'll put that in there. And then now I have the data. If I run that, work a cars, and there's the data set that we're looking at. It's got the entire thing. I'm going to write some code. So remember how I wrote those codes if the make equals this car and give it the variables? That's what I did with the code that I gave you in Canvas. So if make equals Buick, then Buick equals, well, I said all these equal to 0 first of all. And this is, and you notice I don't have Saturn. So when everything's 0, that means it's a Saturn. But when one of these, if the make is one of these things, then that will have. So I'm going to run this code and you can take a look at it. So if we look over here to the right, this is a Buick. You'll notice that, see, Cadillac, oh, actually, let's see. Buick has the 1, Cadillac, Chevrolet, Pontiac, Saab, all of those have a value of 0. Now when we run the regression, we run it. Then we can look at this. We have, let's see, R squared of 72%. Look at the model. Let's see. That's a significant model. If you look at the p-value for each of the coefficients, for each of the parameters, they're all less than 5%. So that's great. And we have the same thing right here. Mileage. If you have every mile that you drive your car, it brings down the price of it by 17.5 cents. If it's a Pontiac, it's going to be that much more, almost $5,000 more expensive than a Saturn. Each store has those values. Okay, well, and so it looks like that's how we run this. That's how you do this in either Excel or in SAS. I hope this YouTube tutorial was useful. Please let me know if you have any more questions. Thank you.